Hello everyone. I invite you to think back to your middle school and high school years. There were probably a lot of social stressors and identity crises and maybe even some pimples, but most importantly, our bodies were going through a cascade of serious physical changes. Some of these changes were visible, but the most important of these changes was occurring inside our brains. You see, during adolescence, the cells in the brain are also growing and changing, especially in the areas of the brain responsible for decision-making, risk-taking, and, importantly, reward. This means that adolescents are much more vulnerable to the rewarding effects of drugs and are therefore more susceptible to developing addictions. Now, drug addiction is very complex, but tends to follow a cycle. Initial use of a drug turns into abuse if someone continues to use the drug despite negative consequences. For some addicts, the damage to their health, relationships, and careers can bring them to try to quit. But it's no surprise that attempting to quit and becoming abstinent is very, very difficult. Unfortunately, relapse is all too common and can be encouraged by a variety of factors, such as drug craving or painful withdrawal effects. Just think of the last time you tried to quit drinking coffee and got massive headaches. As if attempting to quit weren't hard enough, for many drugs, there are no approved medications to treat drug addiction. But this is where my research comes in. In our lab, we use adolescent rats that are also sensitive to the rewarding effects of drugs, such as methamphetamine. By using adolescent rats, we can test the ability of different treatments to block the rewarding effects of methamphetamine. One such treatment we are looking at is called zolmitriptan. You may be familiar with this as an FDA-approved medication for the treatment of migraines. Zolmitriptan works by activating 5-HT1B receptors in reward-associated areas of the brain. Prior research has found that administering zolmitriptan actually decreases intake of both methamphetamine and cocaine. However, this research was conducted in adult rats. No studies have looked at the effects of zolmitriptan in adolescent animals, even though adolescents have been shown to be more sensitive to drug reward. So then how do we know that zolmitriptan will work for adolescents? Well, this brings us to our current study. We administered zolmitriptan to adolescent male and female rats and tested their preference for methamphetamine. As we had expected, these rats demonstrated a decrease in preference. Therefore, zolmitriptan was effective at blocking the rewarding effects of methamphetamine in adolescent rats. These results tell us that zolmitriptan can potentially block methamphetamine reward in addicts who are still using but are attempting to quit. Our future research will determine if zolmitriptan also decreases the intake of methamphetamine in adolescent rats as it had in adult rats. We are optimistic about this research and the potential of zolmitriptan to act as a medication for those attempting to quit use. Since zolmitriptan is already FDA approved, a potential treatment for methamphetamine addiction may be closer than we think.